Okay, geometry fans, our topic for today is inside angles and outside angles. And your joke of the day, to start this off, have you heard the joke about the pizza? I can't tell you, it's too cheesy. All right, so far, as a recap of what we've been doing the last couple days, we've talked about central angles and also inscribed angles, or what I say, on the circle. And what we're doing is we're comparing where the vertex is to what the measure of the arc is. Central angle is the same as the arc measure that it intercepts. So on the side here, for example, if we have a circle and we have an angle at the center, and if we say that that arc measure is 80 degrees, and we want to find the central angle measure, right there, the central angle is the same as the arc that it creates. So it creates 80-degree arcs, so x is equal to 80. That's my answer. Central angle is the same. The central angle is where the vertex is. The vertex is right there. Okay, there's my V for vertex. It's at the center. Now what happens if the angle is on the circle? Well, over here on the side, here's a circle. This time, we'll do 80 degrees again for the arc measure. Here's the arc measure that's intercepted or created. And this time I want x degrees, this angle here. Notice the vertex is now on the circle. So it's a different relationship. We talked about it yesterday. On the circle is half the arc. Central angle measure is the same as the arc. On the circle is half the arc. So you can take 80 divided by 2, and you get x is equal to 40. All right, so today we're going to talk about what happens when the angle is inside and when it's outside the circle. Inside, I'm going to draw a picture here. Let's say that we have two chords, two segments intersecting. Both of these are called chords because their endpoints are on the circle. And we'll say this is x degrees right here. And let's go ahead and say that this arc measure is 120 and this arc measure is 80. Couple things that happen right away. First of all, you notice that the vertex, here's V for the vertex, it is not at the center, it's somewhere inside the circle. Okay, center is somewhere over here. The vertex in this case is inside the circle. Now the other thing that happens though is that because two chords cross, they create vertical angles. And one thing that we know is that vertical angles are always congruent. So this angle here and this angle here are the same, and if this is x degrees, so is this. So now we have a problem, because where these two segments cross, where they hit the circle, they create two different angles. They create here the 120, but they also create the 80, and they're both created by x degrees. So which number do we use, the 120 or the 80? And in this case, you could say the 120 is the bigger arc, and the 80 is the smaller arc. And what happens in this case is that x is going to be the halfway point. It's the average of the two arcs. So I say inside is the average of the two arcs. Now the average means you add them and divide by 2. So what I'm going to say here is big plus little divided by 2. When you average two numbers, you add them, you divide by 2. So what we do is we add the arc measures, we divide by 2, so 120 plus 80 over 2 is going to be 200, and then divide by 2, and what you get is x is equal to 100. So at this point here, central angle, if the vertex is at the center, the angle is the same as the arc. If the vertex is on the circle, the angle is half the measure of the arc. If the vertex is inside the circle, then the angle is the average of the two arcs, big plus little divided by 2. Now we're going to do the outside, but first let's go ahead and do a couple examples with the inside measure. Now the other thing is, the way that I remember this is I sing the song, If You're Happy and You Know It. If it's a central angle, it's the same. If it's on the circle, it's 1/2. If it's inside, then it's average. And I'm going to stop there because we haven't gotten to the outside yet. So we'll do that in a minute. We'll finish that up. But let's do a couple examples. And let's start with number 1 here at the bottom. Find x. All right, so here's x degrees. That is an angle measure. That is this angle here. Now, the thing is, vertical angles are congruent, so we actually have 2 x's. If I trace these out, it intercepts the 123 degrees, that arc, and also the 65 degrees. So inside, the inside angle measure is the average of the 2 arcs. So we're going to take the 2 arcs, 123 plus 65, add those up, and divide by 2. Now this is going to be 188 divided by 2, and your answer is 94 degrees. That's your value for x. It's really important that you add these first. Get one answer, then divide by 2. Number 2. So here's your angle measure. It's somewhere inside the circle. Here's your vertex. You can put a V there if you want for the vertex. So if the vertex is inside, then the angle measure is the average of the 2 arcs. So if I trace this out, that's 55 degrees, and then this is 72. So again, what we'll do is we'll take the average, we'll do 55 plus 72 over 2, and that adds up to 127 divided by 2. You get a decimal, 63.5 degrees, which is fine. That is correct. You can get a decimal. So x is 63.5. Inside angle is the average of the arcs. Add them, divide by 2. Now number 3 here, here's the angle measure. And one thing that you'll notice, here's x degrees, is the 2 arc measures they give you, the 81 and the 147, if I trace those out, that is for these 2 angles here, these 2 vertical angles. That's not what the x is. So I got to find this first, and I can do that. I'm going to solve, I'll call them y degrees. So inside angle, y, is the average of the 2 arcs. Y equals 147 plus 81 over 2. So add these up, you get 228 divided by 2, which is 114 degrees. Now that's not the answer for x, that's the answer for y. So in the picture here, this is 114. So to find x, notice that we get a straight line here, and that these 2 angles are adjacent, the 114 and the x. They're adjacent, they form a straight line. That means that these add up to 180. So all we have to do is take the 114, subtract from 180, and we get the x value, which is 66 degrees. So x is 66. That is your solution. All right, so inside angle is you average the arcs. Add them, divide by 2. Now we're going to flip it on the back, because let's also do 4, 5, and 6. And then we'll come back to the front and do the outside angle. So number 4 says find, and that's arc AB. Arc AB is here, if I trace that out. Now one thing that I like to do is not only trace the arc, but trace the angle that creates it. In this case, it's the 111. That's your angle measure. Now vertical angles, so the other 111 is also creating the 80 degree arc. Here's arc AB, I'm going to call that x degrees. We want that measure. Well, inside angle, here's your vertex. Inside is the average of the arcs. Now when you average the arcs, what you're doing is you are adding the 2 arcs. In this case, it's x plus 80. X plus 80 over 2 is equal to the angle measure. The angle measure is the average of the arcs. So I average the arcs, and what I get as my answer, in this case, is the 111. Okay, so that is the angle measure that's equal to the average of the 2 arcs. Now to solve this, I'm going to make a proportion. I'm going to put this over 1, and I'm going to cross multiply. So I get 1 times x plus 80, which is x plus 80, equals 2 times 111, which is 222, and now it's an equation. We want to move the 80 to solve for x, so we go minus 80 minus 80, and we get x equals 142 degrees. So what we're doing is we're working backwards. If they give you the angle measure, set up the equation, set up the average, and then solve the proportion. Number 5, find arc CB. So here's arc CB. If we trace that, x degrees. Now we have two arcs. We have the x degrees and we also have 39. And they tell us the inside angle is 62. Here's the vertex. It's not a central angle. That is inside. So inside is the average of the arcs. So average of the arcs, we'll say, whoops, average of the arcs is x plus 39 over 2 equals the angle measure, which is 62 degrees. Average of the arcs gives me the angle measure. I'm going to put that over 1 and cross multiply, so we get 1 times x plus 39 equals 2 times 62, which is 124. We got one more step. We're going to go minus 39 on both sides, and we get x is equal to, and that would be 85 degrees. So the answer there is 85. All right, let's do one more. Let's take number 6. Find x. So now x is part of this arc measure right here. This is all 3x plus 1. There's another arc, the 79, and notice that the angle is right here, 100 degrees. The vertex is inside, so central angle is the same. On the circle is 1/2. Inside is the average of the arcs. So to average these, I'm going to add them. So 3x plus 1 plus 79 over 2. That gives me the angle measure, which is 100. Now before we cross multiply, I can simplify this numerator. I can do 1 plus 79, which is 80. So 3x plus 80 over 2 equals 100. Now we're going to cross multiply. I'm going to put this over 1. 1 times 3x plus 80 is 3x plus 80 equals 2 times 100, which is 200. Now to solve it, we'll go minus 80 on both sides. So 3x is 120. And then your last step, to undo the 3 times x, we'll divide by 3. X equals 40. And that's your solution. Now you can check it. If I take 40 and I plug it back in for x, I would do 3 times 40 plus 1, which is 121. So 121 plus 79, if I add those, I get 200. If I divide that by 2, I get 100, so everything checks. So that's the end of part 1. Go ahead, flip it back onto the front, and we'll do the outside angles in part 2.